So, someone at your firm has seen laser scanning. They believe that it is the best way to capture existing conditions, so they had your site scanned. Now you are the proud owner of a huge file they're calling a point cloud. And you're thinking, what am I supposed to do with this thing? The short answer is anything you want. But the how and why are questions that tend to have project-specific answers. This series is designed to provide our clients with real-world examples of the ways that laser scanners can help you work better, faster, and cheaper than the competition. The raw data captured by laser scanners is called a point cloud. You are looking at one right now. But what exactly is a point cloud? A point cloud is a collection of points. Each point exists in three-dimensional space with an X, a Y, and a Z value. They can contain additional values as well, but we'll get to that later. Each point represents a spot where a pulse from a laser scanner struck an object in your site and then returned to the laser scanner. By knowing the distance and the angle from which the laser pulse was sent, an X, Y, and Z value can be derived. When properly collected, each point is a survey-grade position. The question now is, why are point clouds so valued by laser scanning service providers? First, as you can now see, they contain a tremendous amount of information. The sheer volume of data that can be collected in a very short order allows for the documentation of detail at a level that is cost prohibitive with any other system. Second, they are a great bargain. Point clouds are the easiest, least expensive, fastest to produce deliverable in the industry. And lastly, we see point clouds and we see possibilities. Once you have a point cloud on your desktop, your site is at the mercy of every computer program you own. Archive it, model it, draw it, study it, duplicate it, slice it, dice it, whatever you want. It's possible once you have that point cloud. Now let's look at some of the various ways in which we are able to use point clouds. In this project, our client needed board approval from a homeowners association to drill at the end of the HOA's driving range. As you can imagine, there were a lot of questions. Where will you drill? Will the driving range close? What will it look like from my house? By using point clouds, GDM was able to create the environment virtually in all three dimensions at a 1-to-1 scale in a format that allowed for a live demonstration. By showing the exact rig that was to be used for drilling, both with and without a sound wall, in the exact location where drilling would occur, we were able to produce real-time views of the site from the windows and front steps of every house that bordered the golf course. Best of all, the data showed that the Christmas trees that were to be permanently installed for gas collection were virtually invisible in the design location due to elevation changes at the site. Prior to this presentation, the HOA had seen maps, photographic mock-ups, and graphics representing the exact same environment that GDM presented with point clouds. So why did the point clouds work so much better? First of all, they represent the actual site at a 1-to-1 scale. The point cloud is not a mock-up, but the actual source of the data that will be used for machine control during the site preparation. But most importantly, all of the data is in a single, cohesive format that is easy for non-professionals to understand. Instead of providing accurate but disparate data sources that your audience has to combine in their mind, you're presenting everything in one single location. All they have to do is look. The need to document existing conditions is often created by new construction at an existing site. This is another area where point clouds excel at communicating the reality of a site before a shovel hits the ground. Proposed designs can be inserted into the point cloud to aid in optimizing the location of the new construction. Coordinates for tie-in points can be collected without having to return to the field for an additional survey. Clashes with existing systems are easily visible, allowing for rework in the office where it is least costly. Another use of point clouds is as the source data for project websites. GDM uses the Leica TrueView engine to create HTML-based sites that allow users to view and interact with the point cloud using a web browser. The websites work via a free plugin for Internet Explorer. This allows users the ability to view the site from the scanner's point of view while anywhere in the world. Because the images are based upon the point cloud, users can select any position and instantly receive coordinate information. Additional tools include symbol and text insertion, measurement capabilities, and hyperlink insertion. The yellow triangles on the screen represent neighboring scanner positions. These triangles function as hyperlinks to another page showing the site from the link's position. All tools save their work as a view in the website and record all data as an XML file. These XML files can be shared with other viewers privately or uploaded to be viewed globally by all users of the project website. As I mentioned at the beginning of this episode, when we see point clouds, we see possibilities. Nothing demonstrates this better than point cloud data mining. Collecting a point cloud freezes a site in time. At any point after that, you can return to that point cloud to data mine it. Data mining can be used to extract information such as coordinate values or elevation data that can be especially useful in site monitoring. Users can make measurements to order replacement parts or answer questions that were not yet asked during the data collection phase of a project. The point cloud can be used to create other deliverables as well, items such as blueprints or insurance documentation in situations where a site has sustained damage. And finally, point clouds can be encoded with additional values such as elevation coloring, photorealistic RGB values, and more. But most importantly to many, point clouds can be used to create fully realized 3D models in CAD, BIM, and 3D animation programs. This transformation from point cloud to CAD is what we will explore in episode 2. For more information concerning any aspect of technical documentation and visualization, contact GDM through any of the links shown here. If you need project-specific information, email us at laserscan@gpdminc.com.